Welcome to our YouTube channel, Advisor Henchman Engineering. This is your Suraj, and this is Paper and Profit Part 5. So, today we will learn about the rotary lime kiln operations, its bottlenecking, what is the new technology is coming, so how to reduce the specific energy consumption for the lime regeneration. So, this is typically a rotary lime kiln schematic diagram. How it is operating, I will explain. So if you see calcium carbonate, it is decomposing to calcium oxide and CO2 at 1200 degrees centigrade. The raw material limestone and lime mud, it is fed from the feed end and discharged from the discharge end by the action of the heat. This heat can be combination of furnace oil plus producer gas, or methane, PNG, LPG, and by the decomposition the CO2 is being swept to the ESP, and the draft is usually it is minus 15 to minus 20 degree mmWC. So these are the reactions. 100 gram of calcium carbonate yielding 56 gram calcium oxide with the use of this much energy. This is the theoretical one, but usually the raw material is 97% pure. So it has been seen that 100 gram of calcium carbonate will yield to 56 57.32 plus the carbon dioxide, and the energy requirement will be this much. So this is the theoretical one. So if usually it has been seen that industry is satisfied with lime having 80 to 85% purity from the rotary lime kiln, because more than this purity sometime it is beneficial, sometime there is always risk of over burning and overcooking. So energy requirement will be this much. So nutshell, if you see, energy consumption and energy requirement theoretically is less, but in practical operation it is very high. Usually, look, um, so I will explain in the later slide how it is, but let us first understand what are the bottlenecking with this rotary lime kiln. In in rotary lime kiln, it has been seen usually short circuiting of the feed is from rotary lime kiln to ESP. So if means if the dryness even is more than the 75% or 75%, usually all the fines and calcium carbonate powder is swept away to the ESP due to high draft of the scheme. So it means that if the dryness is increasing more than 70 or 75%, instead of giving benefit, it is reversing the fact. Means there is a diminishing margin of lime mud dryness above 75%. Industry is also looking for some innovation to reduce this specific consumption below 6 gigajoule per ton lime to 7 gigajoule per ton lime, because in the most of the industry energy consumption is more than 7 gigajoule per metric ton lime. It has been saying that where the silica content is more than 3%, the energy consumption is as high as 11 gigajoule per ton lime, making the whole operation uh, totally not profitable. It is well understood that lime kiln operation is not profitable, but the energy crisis is known to everyone, and we have to find out wherewithal how to reduce it. Is it possible? I will reveal you all the things in the coming slide. So these are the some of the objective of installing pre-dryer. So prevention of short circuiting of the feed from RLK feed and to ESP, then ESP to back to RLK. So another objective is to produce high purity lime at the optimal cost. Another prime objective is to gain a capacity 10% capacity by installing this pre-dryer, and the reduction of the lime consumption per ton of the pulp, means total cost we have to reduce it. So what actually industry expect? Industry expect a solution. Once the lime mud has fed into the kiln, it should not recycled, means from feed end to ESP, then ESP to feed end. And if even if there is an circumstances that we cannot avoid it completely, this recycling, at least it should be minimized. So what is the trade-off in doing that? So with there is a two thing. Without achieving high lime dryness, cost of the lime production cannot be achieved. Means until the dryness is getting more than the 85%, the cost of lime processing cannot be reduced by the rotary lime kiln. And another thing is that if it is the dryness is if the dryness is more than that, recycling usually happens. So how it will happen? This is the lime sludge briquette machine, which is hydraulically compressing the sludge into some briquette. I will let you know how actually it is working in the lime kiln pre-dryer. So these are the actual pellets which was produced by the this lime sludge briquette machine, which is compressing the lime sludge into briquette. It is hard enough and close to the limestone, but we cannot say it is limestone, but it is hard enough, which is fulfilling our purpose. So this is the lime kiln pre-dryer system. If you see, the CO2 generated and is going through these pellets, there is ample path for the passage of this CO2 and flue gas, but the same time it is preventing the fines to swap away to the ESP. This is the prime objective. So these are the two hydraulic gates where from this lime sludge briquette has to be fed, and this is the central shaft where from we can feed lime sludge as well as limestone to directly. So here feed screw concept is totally removed. So there is no need to install the feed screw conveyor, which is restricting the cross flow area, and the velocity is increasing, and the swaying of the fines actually happen in the technology. So it is avoided here. So all the material can be fed directly here, and this is the chute where from we can remove the briquette and crushed. Suppose in the day one we have fed, and you can keep the whole day, you need not to remove because it may have some moisture. So the next day you can take out the briquette, crush it, and fed it back to the kiln. So this is the process how a lime kiln pre-dryer works. So coming to the point, how to produce low cost lime, low cost as well as a high purity lime from the another technology, because oil gas crisis is known to everyone, and it is not possible to run the mill without lime. So if we are producing the lime from the furnace oil or LSHS or PNG method or PNG or LPG, you will find that the lime cost is very high. So we have to find a process or system by where we can totally produce the lime from the coal itself or producer gas. So here is the technology, how it is, how it will work. So what is the some of the salient features of this state-of-art vertical lime kiln? 90% of the lime mud of 85% dryness will be fed directly. Only 10% of the sludge will be converted into the briquettes. So there will be zero FO or purchase PNG in this kiln. 100% producer gas biomass will be utilized. Biomass means this producer gas has to be generated either from the coal or the biomass, which will be procured in-house. The scope of in-house biogas can also be combined in this burner and can be fired. Methane can be, if produced in-house, can be combusted in this kiln. So lowest possible cost is possible only through this state-of-art vertical lime kiln, which is utilizing almost 90% lime sludge of having dryness more than 85%, and there is a sufficient inventory of the lime. For example, if something in the transit or the supply chains occur, our meal will have sufficient amount of the lime in our silos. So this technology also reduces the emissions, means that the technology is such that the particular matter coming to the ESP will be the minimum one. So this is the state of art vertical lime kiln. A disc is rotating, and over the disc the lime sludge having dryness more than 85% is fed, and through this, if you see, there is a grating, there is enough path for the CO2 to go through the directly to the ESP inlet duct. So in the meantime, it is not allowing fines and other powder to sweep away to the ESP. So for better understanding, I am showing you a top view and side view of the system. So if you see the kiln will look like that. It is a disc over which lime powder is laying there, and it is getting burned over the disc. This disc is continuously rotating, and if you see this picture, this is the side view of that bed, that moving bed. So it is in a conical shape, and it has some angle of repose. Whenever the material is exceeding, it is getting down. So lime produced will be taken out from the state of art vertical lime kiln. So these are the some of the usage. So how much OPEX will be there for this state of art vertical lime kiln? Energy requirement will be the maximum if the dryness is less. Usually it shall be the less than the 5 gigajoule and 5.5 gigajoule, and it will totally use the producer gas. Maximum coal consumption will be 375 kg per ton of the lime kiln. Usually it will be only in the range of 300 to 325, but to make it more pragmatic view, this should be the maximum consumption, and the cost will be this much. So power consumption will be 25 kilowatt per metric ton, amounting to 250 rupees, and the labor charges will be 165. So maximum lime costing in house will be around 3200 metric ton. So this was the technology which is the need of the coming days. So if you see, there is a lot of thing is coming, but we as a industry has to do some R&D and research and some trial in house. So friends, this, I think this video is the very innovative, and people will take forward this concept, and thanks for watching. For such a wonderful knowledgeable videos, we will update to you time to time. Till then, have a great day. Bye bye.